Hi, I am Ele313. This is the fourth experiment of Ele313. In the first part, we will set up the Wien-Bridge Oscillator. Showing the experiment. First, I connected the operation amplifier and externals. This is the minus V, this is the plus V, this is inverting input, this is non-inverting input, and the blue ones are output. We can connect the feedback first, gain the non-inverting input. 2.2K from output to somewhere in the breadboard. And we'll connect the potentiometer to adjust the gain. And the 1K from non-inverting input to ground. Inverting to ground, sorry. The gain is maximum, gain is now. And the next, we'll move this 10K from resistors and 100 non-farad capacitors from output to somewhere. In series, these are in series and these are in parallel. Ground connection from here to ground. Okay, circuit is done. Connecting the power. Okay, circuits. Okay. The minus value of output will be 6.36 not to distort. Voltage difference between output and the ground is 6.44 volts. We can take switch by the LED. Okay, as you can see, the brightness of the in second part we will replace the capacitor to 220 microfarad. Let's do this. Okay, oscillation start. Okay, meter out. Okay, I'm going to the capacitor only. Fixed it, and the output voltage, RMS value of the output voltage is 6.40. Again, the same output, because we don't change the gain of the operational amplifier, we just change the frequency. So we can change the brightness of the output by putting an LED. Okay, this is a little bit lower than the tracer, because the frequency is reduced and the brightness have changed. And that's the third part. We'll replace the 10 kilo resistor set, 1 kilo, and we will connect the 100 microfarad capacitors again. We'll do this. These 10 kilo resistors will replace. It's 1 kilo. One of them here. And the other one's here. And okay. And again, connect the power. And just is not working. The measure output voltage. RMS value. As you can see, the output voltage is a little bit lower because of the frequency. And we can obtain this by dimming the LED again. Okay. If you can see, the LED is less bright. Okay. The Wien-Bridge part of the Wien-Bridge is done, and we can set up the phase shift of an oscillator. Now we can start with the second part. So, in the second part, we'll set up a phase shift oscillator, and our non-inverting input is directly grounded. So, I'm going to directly to ground. Okay, then we can set up the feedback network. We will use 500 kilo potentiometer to feedback resistor, but I don't have 500 kilo resistor potentiometer. I use 2 of 1 megaohm. One of them is potentiometer, and the other is standard 1 megaohm resistor. Okay, this is 500 kilo resistor from feedback network, and the non-inverting input is connected to the output with a 10 kilo resistor. But first, we should set up the RC couples. Okay, these are 220 farad capacitors. And these are 1 kilo resistors. Okay, and last is the 10 kilo resistor from inverting input to connections are done, you can make the power connection. Okay, now the oscillator is working. Let me measure the RMS value from ground to output. It's 6 point something. In this part we will replace the capacitors with 0.47 microfarad, but I don't have 470 nanofarad capacitors, so I'll use some parallel connected combination of capacitors to reach 320 nanofarad. And let me make the power connection. And measure the RMS value. Okay, again 6.20. This is the maximum value. We should obtain the 6.35. And I will connect the LED now. This is the same. You can see the brightness of the LED. And I want to show you something. I want to show the oscillation. If I connect the LED in reverse direction, it's also working. So this shows the oscillation. The LED is working just only in the positive cycle of the oscillation. Okay. And last part. I'll do some combinations of resistors. All the connections are done. We can connect the power. Okay, as you can see, the gain value is the output or RMS of output voltage is 6.18. And with the last step, we'll connect an LED to the output. Okay, as you can see, the brightness is a little bit lower than previous case. I have replaced the capacitors of the oscillator with 10 microfarad. This lowers the frequency of the oscillator, and we can obtain the oscillation by these LEDs. Green LED flashes the positive cycle of the oscillation, and the red LED flashes when the negative cycle of the oscillation. Let me do the power connections. As you can see, the frequency is low, and we can adjust the gain of the oscillator, but not frequency. I have also created an amateur oscilloscope based on Arduino. The ground of the oscilloscope is minus 2.5 volts using a 7805, and the output of the oscilloscope is reduced to 5 volts to by a volts divided network here. And let's see that slope. Okay. The sampling rate of the scope is 1 kilohertz, 1 kilo sample per second, and if you connect the scope, we get this waveform. As you can see, I can adjust the gain of the oscilloscope by this potentiometer. As you can see, it's go to saturation, so the top and bottom of the waveform is distorted, and I can reduce the gain. And also, okay. This waveform is good. Thank you for watching.